Hello everyone, welcome to my YouTube channel. In this session, I am going to explain the method of obtaining solution of second order ordinary differential equations by the method of variation of parameters. Here, to find the solution, there are 4 steps. In step 1, we have to write given differential equation in the form f of d into y equals to phi of x, function of derivatives into y equals to phi of x. After that, first we have to find complementary function. We know the method of obtaining complementary function. First we have to write auxiliary equation f of m equals to 0 just by replacing d by m and find the roots by the nature of roots. Write down complementary function in the form yc equals to c1 y1 plus c2 y2. Here c1 c2 are unknown constants, y1 and y2 are the solutions based on the roots of auxiliary equation. Next, in step 2, assume y is equals to a into y1 plus b into y2 be the complete solution of differential equation. This equation obtained by just replacing unknown constants c1 and c2. Replace c1 and c2 by a and b. A and b are function of x, a of x and b of x. Next, step 3. Then compute y1 dash and y2 dash. It means here coefficient of a is y1 and coefficient of b is y2 and find out their derivatives y1 dash and y2 dash. We know that here is the function y1 and y2, their derivatives y1 dash and y2 dash. By substituting these terms into the formula Wronskian defined by y1 into y2 dash minus y2 into y1 dash. Substituting these values into this formula, you will get W means Wronskian. Next, step 4. Then we assume these expressions for A dash and B dash in the form, look at it. These are the formula given for A dash and B dash. A dash is given by minus y2 into pi of x by W. B dash equals to y1 into phi of x by W. Here y2 is the function and phi of x is the RHS of given differential equation. W is the Wronskian. Substitute into the formula, these two formula, and by integration we get A and B. These are A dash and B dash. By integrating on both sides, we get A and B. Substitute this A and B into our assumed solution, complete solution. Here, A into y1 plus B into y2. Substitute into the x in this equation. You will get complete solution of given differential equation by the method of variation of parameter. This method is called variation of parameter because we are replacing unknown constant by functions of x, functions of independent variable, and finding these functions we are obtaining the solution, complete solution of given differential equation. Therefore, it is called variation of parameter. Let's see one problem based on variation of parameter. Suppose the problem is solve y double dash plus a square y equals to secant ax by the method of variation of parameter. First write down given differential equation in the form d square plus a square into y equals to secant ax. D square means second derivative. In the next a square is constant into y equals to secant ax. It is in the form f of d into y equals to pi of x. So first we have to find complementary function. For that, auxiliary equation f of m equals to 0, m square plus a square equals to 0 just by replacing d by m and find the roots. Roots are m equals to plus or minus square root of minus a square. It becomes plus or minus I into a. This is a complex root. Therefore, complementary function becomes yc equals to c1 cos ax plus c2 sin ax. Here it is in the form p plus iq, here p value 0, therefore e power px, e power 0x is 1 into c1 cos qx plus c2 sin qx, q value is a. And next we have to replace unknown constants c1, c2 by the functions a of x and b of x. Next, assume that this is a complete solution of given differential equation. It is in this form. Here coefficient of a is y1 and coefficient of b is y2. So write down here y1 and y2. Find out their derivatives. After that, find out the Wronskian by using the formula. Substituting into formula, we get the Wronskian equals to a. After that, consider the formula for a dash and b dash. Substitute all the terms y2 phi of x and w. Here y1 phi of x and w. Substitute the terms. Here we have secant ax. In a dash we have secant ax in the numerator. It can be written as 1 by cos ax, and sin ax by cos ax becomes tan ax. And similarly in b dash, secant ax can be written as 1 by cos ax. Cos ax will get cancelled. B dash becomes 1 by a. And here a dash is minus 1 by a tan ax. On integration both sides, we get a dash, integration of a dash is a, and minus 1 by a integration of tan ax dx plus integration constant k1. Here integration of tan ax is log secant ax by a. And after simplification, we get a equals to minus log secant ax by a square, a into a square plus k1. And here b dash is 1 by a. On integration, it becomes 1 by a is constant. Integration of dx is x by a plus integration constant k2. Substitute this a and b into the equation 2, means complete solution, assumed solution. Y equals to a cos ax plus b sin ax. Substitute a and b here. This is the complete solution of given differential equation by the method of variation of parameter.